It's time for another amazing chemistry video with Mr. Stapleton. Proudly sponsored by Farmers Really Nice Coffee.
Hi guys, welcome to this video, which is part of the organic chemistry topic. This video is going to be all about amines. Now the amine functional group is one which is a nitrogen, okay, like this. So nitrogen, because it's in group 5, it is able to form 3 bonds around it. So what each nitrogen actually has is a lone pair of electrons up here, okay? And then what you can actually do is have 3 bonds coming off the nitrogen. Now in an amine, there are 3 different types of amines you can have in organic chemistry. And so the first one you can have is what's called a primary amine. So a primary amine looks like this, okay? And we call this R for any sort of carbon chain in there. It can be hydrogen, so you could have ammonia. That's the most basic amine you can have. But that's what we call a primary amine. And they are distinguished by having 2 hydrogens on the nitrogen or 1 carbon attached to the nitrogen as well. The second type of amine you can have is, not surprisingly, a secondary amine. And that differs a little bit in terms of you have 1 hydrogen attached to the nitrogen, but then you've actually got 2 R groups on it. Okay? So a secondary nitrogen only has the 1 hydrogen on the a secondary amine only has the 1 hydrogen on the nitrogen. The third type, as you probably guessed, is the tertiary, and the tertiary amine has carbons attached to the nitrogen all the way around. Okay, now they don't have to be the same carbon. All right, they can be different types of carbon chain lengths. Okay, they can be the same, but they're not always, and that's a tertiary amine. So just as in alcohols we had primary, secondary, tertiary alcohols, here we've got primary, secondary and tertiary amines, which is determined by the number of hydrogens that are actually attached to the nitrogen. So 2 for a primary, 1 for a secondary and none for a tertiary. Sometimes you might see a tertiary amine, which is drawn a little bit like this. So you might have a nitrogen and it's double bonded to a carbon this way and bonded to a carbon this way. Okay, that's another example of a tertiary amine, because again there's no hydrogens attached to it, so it's going to be tertiary even though there's only 2 carbons attached. Okay, so what you need to be able to know in this topic of amines for organic chemistry is how to name them firstly. And how to name amines is pretty straightforward. Okay, all you've got to do is every amine ends in amine, okay, and what you do is you give the number of the carbon atom that is attached to. So if you start with one very simply like this, NH2, okay, 2 carbons, 1 nitrogen on there, the amine group on the end, so this is going to be F, and so it's for ethane, right? Ethane amine will be this amine that we've got here. We don't need to write 1 amine on here, because regardless of which one on, it's going to be on the first carbon, whether it's at this end or this end. So you just name it that way. If you had more than that, so if you had this one, the amine is on a secondary carbon there. We've got 4 carbons in the chain. It will be butan 2 amine. Okay, so they're really, really straightforward to be able to name them. You can have more than 1 on there. So if we put another NH2 group here, if we change this to be a nitrogen here as well, an amine group there, it would be butan, I might struggle to fit this in, but 2, 3, and then we'd have diamine in there as well. So they're pretty straightforward in terms of naming. The really interesting thing about amines is their use in organic chemistry, and in particular related to their use in drug synthesis. So that's what I'm going to talk about now. Now, the fact that they can be used in drug synthesis comes down to this key fact over here with the nitrogen, that it has a lone pair of electrons. And it has that because it's in group 5 with 5 electrons around it. So when you bond up and form 3 bonds, you've got 2, 4, 6, 8 electrons around it to make it stable, have a full outer shell. Now that lone pair of electrons is really, really important, because what it can do is it makes an amine behave as a base. Okay? Now that's really important because a base is also known as a proton acceptor. Okay? And by a proton we mean a H+. Okay? So what happens when a nitrogen with a lone pair of electrons on it, okay, comes into contact with a hydrogen ion, this lone pair of electrons actually form the bond towards the hydrogen, and that's called a coordinate covalent bond. Now, that coordinate covalent bond means that the nitrogen, which has the 3 bonds on it normally, now has a bond to a hydrogen, and we now get a positive charge on the amine. This is what we call a protonated amine. Now, protonated amines are really useful in organic chemistry because what they can do is form really strong ion dipole interactions with water. So these ion dipole interactions, so if I write that down for you, ion dipole interactions are the same sort of things as you get when you have like a sodium carboxylate salt or a potassium carboxylate salt that we looked at in carboxylic acids. They're really good at forming ion dipole interactions with water. Now, the fact that they can form ion dipole interactions with water means that they now turn the drug into a water-soluble form, which is really beneficial because a lot of organic drugs are very large non-polar molecules, and because blood is majority water, you need something that's water-soluble so it can get around the body. Okay? Protonating an amine, and you do this by normally just reacting it with an acid. Alright, so hydrochloric acid is a really good example, just supplies the proton. The basic nitrogen here, through the lone pair of electrons, attracts the hydrogen to form this protonated amine, and through the ion dipole interactions, that makes it water soluble. Now, the really good thing is it doesn't matter if it's a primary, a secondary, or a tertiary amine. All of these nitrogens here still have a lone pair of electrons, and that lone pair of electrons is what is responsible for forming the coordinate covalent bond to the hydrogen, which allows the protonated amine and hence water-soluble form to be formed. Alright, so it's really useful in organic chemistry, and that's really the key thing they're going to pick up with you as you're going through year 12. They'll be able to ask you to identify if it's a primary, secondary, or tertiary amine, and then they'll be asking you, they might ask you to name them, but more than likely they're going to bring in about protonating the amines and why that's beneficial. So all you've got to do, whether it's primary, secondary, or tertiary, is draw a hydrogen in on the nitrogen like we've done here, and put your positive charge on the nitrogen, because that's where the charge actually resides now. And that protonated amine is able to form those ion dipole interactions with water to make it water soluble. Amines will come up again shortly when we look at amides, and they're used to make amides, and we'll look at them a little bit more there. But for the moment, I just say practice identifying primary, secondary, tertiary amines. Just Google amines and have a look at them, see if you can identify what's what. And in particular, practice drawing the protonated form. It's really straightforward, as I said, just put a hydrogen on the nitrogen and put a charge on the nitrogen here, and there's your protonated form. Alright, I hope this has been fairly straightforward for you. As always, if you've got any questions, just ask, and thanks guys.